Welcome to the first video lesson of Math 107. This is from the P1 section, and it is on equations and solutions of equations. So an equation in x, we usually use x as a variable to hold things, is basically a statement that two algebraic expressions are equal. For instance, 2x minus 6 is equal to 12, right? These are two different algebraic expressions set equal to each other. And this is an actual equation. An equation has an equal sign. Okay, it's like a full sentence. Like 2 times the number minus 6 is 12. It has a verb in it. Like 2x minus 6 is just an expression. It's not equal to anything. And 12 is also just a number and not equal to anything. So it's the fact that the equal sign is between them that makes this an equation. So x would be a value, a solution that would make this equation true would be a value for x that makes my equation true. It's not too terribly hard to guess and check our way to find out that if x is equal to 9, then 2 times 9 minus 6 is equal to 12. So x equals 9 is a solution to our simple equation. Also, if another type of equation, if I have x squared minus 2x minus 15 is equal to 0, this is also an equation. It has an equal sign. It means that the left side should equal the right side. With a little playing around, this one maybe isn't quite as obvious, but x equals 5 is a solution because if I plug in 5, I get 5 squared minus 2 times 5 minus 15 is equal to 0, which means I have 25 minus 15, or actually minus 10, I'm sorry, minus 15 equals 0, and 25 minus 10 minus 15 is 0, 0 equals 0, so x equals 5 is a solution to our equation. This one also has another solution. X equals negative 3 is also a solution because if I try it, let's see what happens. I'm plugging my negative 3 in for x. I have negative 3 quantity squared. Whenever I'm plugging a value in for x and I'm plugging it in for x squared, I always treat it like it's in parentheses. Then I have minus 2 times negative 3 minus 15 equals 0. Negative 3 quantity squared means negative 3 times negative 3, which is positive 9, minus negative 2 times negative 3 is actually plus 6, minus 15 equals 0, and 9 plus 16 is equal to 0, so I get 0 equals 0 again, right? So x equals negative 3 is a solution. If I try any other number for x, let's just try x equals 1 for instance, then I plug in x equals 1 into my x squared. I'm plugging it into this equation right here. Then I get 1 minus 2 minus 15 equals 0, and this is not true, right? So you're going to have to take my word for it right now, but x equals 5 and x equals negative 3 are the only two numbers that actually, when I plug them into this particular equation, makes it true. That makes them solutions to this equation. Something that's coming our way, just so this is just a little bit of a heads up so you get used to some of the vocabulary, but this first equation that I started with up here is an example of what we call a linear equation. This one here is what we call a quadratic equation. So I'm just introducing a little bit of vocabulary right now. We don't really know any details about them, and we'll get deeper into it later. Okay, so let's look at another type of equation. Okay, so this next one, again, we're just guessing and checking right now, just sort of getting an idea of what an equation is. If this seems really basic to you, don't worry, we'll pick up speed at a really fast pace. So this next equation is what we call a radical equation. It's the square root of x plus 3 equals 4. And so again, it's an equation because there's two things that are equal to each other. On their own, without the equal sign, the square root of x plus 3 would just be an expression, and the same thing with 4, it would just be a number and not an equation. So I do know that the square root of 16 is equal to 4, so I know that what I want to have underneath my radical is 16. So if x is equal to 13, that should give me the square root of 13 plus 3 equals 4. And since 13 plus 3 is 16, that is in fact 4. So again, x equals 13 would be a solution to this is actually what we call a radical equation. Again, this is just some terminology I'm just trying to get you used to right now. Okay. So this is an example of an equation, and the way that I can tell if something is a solution to my equation is just to plug in the number and see if it makes it a true statement. Okay, so this makes it a true statement. X equals 13 does in fact work. Okay, so we're coming up to our first definition. All right, so our first definition is solve. Now hopefully most of you have heard of this word before, and basically it just means we're going to find the values of x, the variable, a lot of times we do use x in pre-calculus, that make the equation true. So all of those solutions that we just checked, for example, the x equals 13, that was what we were doing, we were just sort of guessing and checking to solve, but those values solve the equations that we just used. Okay. And then the solution is in fact a value that makes the equation true. So solve is the act of finding the solution, and the solution is the actual number that makes it true. Okay. So let's look at a couple of different types of equations. Again, I have x squared minus 2x minus 15 is equal to x minus 5 times x plus 3. So let's just plug in numbers for this and see what happens, okay? So if I plug in x equals 0, so when x equals 0, then I have 0 squared, which is 0, minus 2 times 0, which is 0, minus 15 is equal to, I plug in 0 and I'm going to get 0 minus 5, which is negative 5. I'll keep them in parentheses. And then I have 0 plus 3, which is just 3. So here I have negative 15 on this side, and here I have negative 15 on this side. Okay, so basically when this happens, this is kind of a special type of equation. It doesn't really matter. Let me try another number. Let me try when x is 1. Let's try again. When x is 1, then x squared will be 1 minus 2 times 1, which is 2, minus 15 is equal to 1 minus 5 times 1 plus 3. So on this side I'm going to get 1 minus 2, which is negative 1, minus 15, which is negative 16. On this side I'm going to get 1 minus 5, which is negative 4, and 1 plus 3, which is positive 4. Negative 16 is equal to negative 4 times 4, which is also negative 16. This is a special type of equation. It doesn't matter which value for x that I put in. It's always going to make it true. We call this an identity. It means that any value that I could possibly come up with will make my statement true. So there's our next definition here. Let me pull this back down. An identity is an equation that is true for every element in the domain. Now I haven't properly used the word domain and defined it before, but domain is just another word for values of x's that we're allowed to use. So officially it's called the set of all real numbers for which an equation is defined. Okay, it just means that these are the numbers that we're allowed to plug into x. All right. So the previous equations that we were solving, for instance, this radical equation that we're currently looking at, x equals 13, it's not true for all values of x. For instance, just really quickly, if I plugged in 0 in here, I would get the square root of 0 plus 3 is equal to 4, and that would give me the square root of 3 is equal to 4, which is not true. So these are an example of a conditional statement. And a conditional statement is basically a statement that's only true for some values of x. So that's our next definition of this particular one, an equation that is true for just some or even no values of x. So let's find one that doesn't have a value. So for instance, let me use another sheet here. Let's try out this one here. we have 3x minus 2 is equal to 3x plus 2. Okay, so no matter what value that I plug in, for instance, if I plugged in x equals 0, I definitely get a failed statement. I get negative 2 equals 2, and this is not true. And it really doesn't matter what I put in, because if you think about it logically, if I have 3 times a number, right, I'm gonna use the same number on both sides of my equation. So for instance, what if x is 2? So I'm gonna have 3 times 2, which is 6, in the first piece of each one of my equations. So there's no way that 6 minus 2 can equal 6 plus 2. And it doesn't matter what value of x I'm going to use, there's never a solution. So this is a no solution case, which falls under the conditional case. In this case, there's no condition that actually fulfills it, but it still falls under conditional. All right, so we also want to talk about, I just briefly introduced something that looks, I said the word linear, so that's the next thing that we're going to talk about, a linear equation. I hope this isn't new terminology for you, because I am sort of going through it quite quickly. If you need additional help, please ask at any time. A linear equation is in the form ax plus b equals c, okay, where a, b, and c are just numbers. We'll call them real numbers, okay? And so the key to knowing that it's linear is that there's one x value. There's no other x's in it, and a, b, and c are just numbers. These all have exactly one solution. And these are the most basic ones. These are the easiest ones to solve. And so we're going to step into that really quickly. So basically what we want to do is, when we're solving an equation, let's just choose this. We'll use this because we used it before. 2x minus 6 equals 12. What if I couldn't figure out on my own? I'm just like, oh, I just don't know what this is. So what do I do to figure this out? Well, essentially, we write in a list of equivalent statements to get us to the point where we get x by ourselves. And we do that by using some different properties. So some things that we're allowed to do with linear equations, actually with any equation, is we are allowed to add or subtract the same value from each side of the equation. It's like a balance scale. Let's fix that so that you can read that. Add and subtract the same value from each side of the equation. You're also allowed to multiply or divide by the same value. On each side. Okay. All right, so let's look at this and we'll see what happens here. We'll use these ideas. Okay, so the idea is to basically get x by itself. So if I start with 2x minus 6 equals 12, so we always want to undo any addition and subtraction first. Okay, we always do that first. And that's because when we are going forward with our operations, we always multiply and divide and then add and subtract. So when we're going backwards, we add and subtract first. So I want to get, my goal is to get x alone. Here is x. It's with this 2. This, when they're touching like that, that means multiplication. So 2x minus 6 equals 12. I don't want this minus 6 on this side. So I want this to be just plain 2x. So basically I want that minus 6 to become 0. So if I add 6 to that side, then negative 6 plus 6 will actually be 0. So that's what I'm going to do here. I'm going to add 6. But I have to remember that this is a balance scale, so I need to add 6 to this side too. So I only add and subtract like terms. Those are things that look alike, right, and have the same power on them. So I have 2x, and I have no other x's, so this side remains 2x. Then I have negative 6 plus 6, which ends up being 0, which I won't write, is equal to, now I have 12 plus 6 on this side, which is 18. Okay, I don't have any more addition or subtraction on either side. So then the next thing I do is multiply or divide. I undo it, okay? So 2x equals 18. My x is here touching this 2, which implies that that's multiplication. To undo multiplication, I divide. So I'm going to divide both sides. I can never do just one side of anything. I divide both sides by 2. And I get 2x divided by 2, which is x, equals 9. And so I came up with the exact same solution as I had previously. So let's do one that's a little bit more challenging than that. Usually people find that fractional type of equations are usually kind of a bit of a more challenge. Okay, so I have 2/3 x plus 4/5 x equals 4. So I have a fraction, and so something that we didn't have in our previous equation is I have two values of x on the same side. So anytime I have an equation, I look at each side of the equation kind of separately, and I can combine any like terms. That means I can add any numbers that are together on the same side, I can add any variables that are on this. I want to make it as simple as possible. So I have two different values of x's here, so I need to add them together. Now, I'm a little bit more complicated here because my values of x are fractional, and I can only add and subtract fractions when they have the same denominator. So I have to be able to cut them basically into equal pieces. So the least common denominator, I can always find a denominator by multiplying 3 and 5 together. So the two different fractions that are there, the denominators are 3 and 5. So 3 times 5 is 15. So I want to make my new denominator 15. Okay? So basically, I have this 2/3 x, and I need it to have a 15 in the denominator. So I know I need to multiply 3 times 5 to get 15. So I also do the same thing to the top. So I have 2 times 5 on top, which is 10, 3 times 5 on the bottom, which is 15, and then the x comes along. So that's how I get 10/15. That's the same thing as 2/3 x. Okay, so I put my little multiplication. The x in here is the x, the variable, and then the dot is the multiplication. So I need to also make 4/5 x, right? I need this to be equal. I need to multiply it by something to make it into 15ths. Okay? So 4/15, I need to multiply 5, this time by 3 to get 15, so I multiply the bottom, and of course I have to do the same thing. It's like I'm multiplying by 1, so I'm not changing the value of it, I'm only changing the look of it. So 4 times 3 in the top is 12, 5 times 3 in the bottom is 15, and I end up with, so I have plus, and then the x comes along, 12 over 15, x equals 4. Now I'm probably going to have to change my 4 as well, but for right now I'm just adding the left-hand side. So now once I get my denominators, all the work happens in the top, because the denominator of a fraction really is just telling you how many pieces it's cut into. So the top is telling you how many you're basically exchanging. So I have 10x plus 12x, which is 22x over 15 equals 4. Okay. So now I need to get x by itself. So I am dividing by 15 here, so I need to multiply both sides by 15. I can do it in one step or two steps by multiplying by the reciprocal. The goal is to get 1x here. So I'm going to multiply by 15 over 22 here, because that's the reciprocal, and the definition of the reciprocal is that when I multiply it, the two things together, I get 1. So I'm going to multiply by this on this side too, because I always do the same thing to both sides of my equation. So now this on this side gives me just plain x, because I'm going to get the exact same values on the top and the bottom, which simplifies to 1. And then I have 4 times 15 over 22. So my x is equal to 4 times 15 over 22, which we can think of 4 as an integer and call it 4 over 1 times 15 over 22, and I multiply straight across and get 60 over 22. So that's my value for x. So I can also simplify this because it is both my numbers are even, so I can divide by 2 here, divide by 2 here, and get 30 over 11. So this is my answer in simplest form, but the 60 over 22 is also equivalent. Okay, so we will practice more examples in class. I will see you next time.